Good morning to all. Myself Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, SIRT, the SAGE Group of one. Today we will discuss the Constraint Application Protocol, message types, and the request response model for the same, that is the Constraint Application Protocol. That is inside the subject, that is IT-703B, Internet of Things, for the same 7. The Constraint Application Protocol, the structure of the Constraint Application Protocol is the most important key, which is to avoid the message fragmentation. So that the constraint application protocol package could be fit in one single frame at Ethernet or IEEE 802.15.4 layer. So main thing was that to avoid the message fragmentation. In the constraint application protocol stack, the two layers, first the message layer and request and response layer. The message layer is designed to deal with the UDP and asynchronous switching, while the request and response layer that is responsible to handle the communication method. Here, this is the constraint application protocol stack, which consists of physical channel, Ethernet, wireless personal area network, IPv6, IPv4, 6LoWPAN, UDP, DTLS used for the security point of view, CoAP messaging, and the constraint application protocol request and response and applications. This was regarding the constraint application protocol stack. Now the constraint application protocol messaging model. In the messaging model, the message layer that supports 4 types of the messages, while the constraint application messaging model is based on the exchange of messages over UDP between endpoints. The message layer that supports the 4 type messages, which include the CON, known, ACK, and RST. CON, confirmable; known, non-confirmable; ACK, acknowledgement; RST, reset. The protocol provides the reliability through the message as confirmable, that is CON. This type of message usually retransmitted be in a default timeout and decreasing counting time extensively until the recipient sends an acknowledgement message ACK with the same message ID. The reliable message transmission using the CON. Here, the client requests to the server when the send to a message to the server. When the server take the message, receive the request, then the acknowledgement is sent along with the message. The unreliability of message transport is carried through known type message, which does not require acknowledgement, but this message contains ID for supervising in case of the retransmission. Means the reliability of message transport is carried through the known type, non-confirmable, which doesn't require any acknowledgement, but this message contains ID for supervising in case of the retransmission. Message layer. Constraint application protocol message format contains the fixed length 4-byte header that may be followed by compact binary options and a payload. This message format is shared by the request, and here inside the message format there is the VER TOC code, message ID, token, option, and payload. Let us discuss one by one. The VER 2-bit unsigned integer indicates the constraint application protocol version number. T 2-bit unsigned integer indicates if this message is of type confirmable, non-confirmable, acknowledgement, or reset. Confirmable means 0 means confirmable, 1 means non-confirmable, acknowledgement means 2 means acknowledgement, and 3 means the reset. code. 8-bit unsigned integer, the request message 1 to 10 or the response message 42 to 255. Message ID 16-bit unsigned integer in network byte order identifier for matching message responses. TKL for token 4-bit unsigned integer indicates the length of the variable length token field 0 to 8 byte. Options. 0 or more optional fields may follow a token. A few options like content format, accept, maxes, e-tag, URI-path, and URI queries. So this was regarding the message format. Now we are coming on the message type of the constraint application protocol. There are the 4 types of the message. That the conformable, non-conformable, piggyback, and separate. Now we are discussing regarding the message type of the constraint application protocol, and we will discuss here the 4 types, that is the conformable, non-conformable, piggyback, and the separate. Conformable mode represents the reliable transmission. Non-conformable mode represents the unreliable transmission. Clear? Conformable mode represents the reliable transmission and non-conformable mode represents the unreliable transmissions. Piggyback is used for client-server direct communication where the server sends its response directly after receiving the message. That is the piggyback. Is used for the client-server direct communication where the server sends its response directly after the receiving the message and within the acknowledgement message. While separate mode is used when the server response comes in a message separate from the acknowledgement and may take some time to be sent by the server. Means in the separate mode where the server response comes in a message separate from acknowledgement, while in case of piggyback the response comes directly after receiving the message within the acknowledgement message. Here acknowledgement is different, message is different in case of the separate mode, and may take some time to be sent by the server. Constraint application protocol that utilize the get, put, push, delete message request. Which one? Get, put, push, delete message request. That stands for, that is the get, that is the for retrieve, put for create, push for update, and delete for delete, like the hypertext transfer protocol. So here we see that the message type conformable, non-conformable, piggyback, and separate mode, and along with the message request that is utilized by the constraint application protocol. The conformable type message, the recipient must exactly, explicitly either acknowledge or reject the message. It's the beauty of the conformable type message. Either acknowledge or reject. So some confirmation has to be received. In the non-conformable message, the recipient sends the reset message if it cannot process the message. Recipient sends the reset message if it cannot process the message. That is the beauty of the non-conformable type message. Now more regarding the message type, the constraint application protocol that utilize the get, put, observe, push, and delete message. For get for retrieve, put for create, observe for initiate, push for update, and delete for delete subscriptions. Supports the caching capabilities to improve the response time and reduce the bandwidth consumption. Use IP multicast to support data requests sent to a group of devices. Specialized for machine-to-machine communication. This was regarding the constraint application protocol. Now we are coming to the request response layer. But before, Myself, Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, SIRT, the SAGE Group. One. Now we will discuss the request and response layers. The request response could happen in two ways: piggybacked or separate response. Piggybacked and separate response. In the piggyback request, the client sends the request and server gives the acknowledgement. Right? Here the client, that is the con, acknowledgement, that is 404. The piggyback, where the client sends the request using the con type and non-con type messages. Piggyback, in the piggyback, the client sends the request using the con type, confirmable message type, and the non-type message and receives response acknowledgement message immediately. That depends. In the con type, the acknowledgement comes along with the message. In the non-type, non-confirmable, the message and acknowledgement that comes separately. This is the separate request response transmission in. Now see, in separate response message type, when the receiver receives the con type message but not able to respond to this request immediately, it will send an empty acknowledgement message. When response is ready, it will send a new con to client and client reply a confirmable message with acknowledgement. Now say, this is the con, only acknowledgement come after some time. The new con to client and client will reply with the acknowledgement, the confirmable message to the client. This was the separate request response transmission, where in the separate response message, earlier we had done piggyback. Okay, in separate, in this, the message is been received by the server and not able to respond immediately the request. Only empty acknowledgement is sent to the client, and after some time, new confirmable message is sent to the client, and client has to reply a confirm message with the acknowledgement. This is the scenario. That is in case of this separate request response transmission. Now this is here the constraint application request response model, where these you see the client and server. Here the confirmable message, acknowledgement plus data, and this is the confirmable, that is acknowledgement plus data. Now here in the client and server, that is the architecture. Here this is the piggyback message. In the piggyback, the acknowledgement data they come along with. While in case of the separate message, when the confirmable message, that is the to server, immediately the acknowledgement comes that without the message. After that, the confirmable message is sent to the client by the server, and the server have to give the acknowledgement. This is here. This client replies the confirmable message with the acknowledgement. This was the constraint application protocol request response model. Now this is the confirm message. This is the non-confirmable message. In the confirm message, when the client sends the message, this is the cone, the acknowledgement comes. While in case in the non-confirm message, that is the non-message. Now this is the non-confirm message. We have earlier done the non-confirm message here. This was in the non-confirm message, unreliable transmissions is there. Right now, there are some features of the constraint application protocol. It reduces the overhead and parsing complexity. URL and the content type support for the discovery of resources provided by the non-constraint application protocol service. simple subscription for a resource and resulting push notification, simple caching based on maximum message is. These were the some features of the Constraint Application Protocol. Now here, there is some comparisons, characteristic comparisons, and here there is the architecture, QoS service, and security and transport regarding the MQTT, MQTT SN, and the Constraint Application Protocol. In the architecture, the MQTT used the publish subscribe architecture via the broker. The same is used in the MQTT SN, and Constraint Application Protocol client server architecture is used. Quality of service, QoS 0, fire and forget, QoS 1, message delivered at least once, and the QoS 2, message delivered exactly once. In the MQTT SN, the QoS 1 and QoS 2, message confirmed by the receiver with the acknowledgement, and QoS 2, message delivered exactly once. Where in case of the Constraint Application Protocol, confirmable message and the non-confirmable message confirmed by the receiver with the acknowledgement, and non-confirmable message fire and forget. This is the scenario. While in case of the security, there is the security, the TLS, transport layer security, depends on the network technology in case of the MQTT SN. While in case of the Constraint Application Protocol, the DTLS, datagram transport layer security, has been used for the security. And the transport via the TCP, MQTT SN via the UDP, and the Constraint Application Protocol is via the UDP. So here are some references, and thank you. Myself, Dr. Kumar, Department of IT, Sagar Institute of Research and Technology, SIRT, the SAGE Group, Bhopal, welcomes you. And thank you for watching the video.